Hello and welcome. Today we're going to talk about a piece of tech that has completely changed the game for how we build stuff for the cloud, AWS Lambda. If you've ever wanted to build powerful, scalable applications without the absolute nightmare of managing servers, then this is for you. So let's dive in.
Really think about that for a second. What if all the time, all the money, all the pure stress you spend provisioning, patching, scaling, and just worrying about servers could just go away? This isn't some far-off future idea. It's the real promise of what we call serverless compute.
And this table just lays it all out perfectly. On the left, that's the old world. You're the server admin. You've got to provision them, manage them, set up these super complex scaling rules, and you pay for them 24/7 even when nobody's using your app. Now look at the right. That's the serverless way. AWS handles all of that for you. It scales instantly, and you only pay for the exact milliseconds your code is actually running. Your focus just snaps from infrastructure to what you actually care about, your application.
So, to really appreciate just how cool the new way is, we have to feel the pain of the old way. Let's talk about the real, and often hidden, costs of keeping those servers running.
This analogy is just perfect. When you have traditional servers, you're not just buying the metal box. Oh no, you're paying for the power, the cooling, the security patches, the OS licenses, and the experts you have to hire to manage the whole thing. And yeah, just like a car that's parked in the garage, you're paying for all of that capacity around the clock, even if you only get a trickle of traffic at 3 a.m. It is a massive operational and financial headache.
And this is where the story gets really good. The solution to all that mess is a concept called serverless, and the star of the show on Amazon Web Services is a service called AWS Lambda.
Okay, first things first, let's get the definition straight. Serverless is kind of a funny name, because of course there are still servers. The whole point is they're not your problem anymore. The cloud provider, AWS, takes care of everything. They dynamically find a server, allocate the resources, run your code, and then tear it all down. You, the developer, don't have to manage a single thing.
And AWS Lambda is the engine that makes this all possible. It's a pure compute service. You just upload your code, they call it a function, and Lambda handles the rest. It just sits there, listening for triggers, and when a trigger happens, it runs your code in a super reliable environment. It handles all the scaling, all the patching, all the management. It's all done for you.
So what are Lambda's superpowers? Let's break it down. First, no server management. That's the big one we've been talking about. Then it's event-driven, which just means your code only runs when something specific tells it to. Next up, automatic scaling. If you get one request or a million requests, Lambda doesn't care. It just scales to meet the demand. And finally, the real kicker, the pay-per-use model. This completely changes how you think about cost.
So, how does this actually work in the real world? It sounds a bit like magic, right? Well, in this next section, we're going to pull back the curtain and see exactly what happens from the moment an event occurs to the moment your code executes.
Right. It's one thing to say it's event-driven, but what does that really mean? How does a chunk of code just wake up and run all by itself when something happens out there in the cloud?
This is the classic example, and it's so powerful. Let's say you're building a social media app. In step 1, a user uploads a new profile picture. They save it to an Amazon S3 storage bucket. That upload, that's the event. In step 2, S3 is set up to automatically send a little notification, the trigger, over to Lambda. And boom, step 3, your Lambda function wakes up, grabs the info about that new image, runs your code to create a nice little thumbnail, and saves it back to S3. This all happens in a flash, with 0 servers for you to think about.
And it's not just about file uploads. The list of things that can trigger a Lambda is huge. You can run a function when something changes in your DynamoDB database, or when an HTTP request comes into your API. Or you can just run it on a schedule, like a good old cron job running a report every night. This flexibility is what lets you build these incredibly powerful reactive systems.
Oh, and let's talk about money. Or rather, not spending it. Look at that number. 1 million. That is how many free requests you get from AWS every single month, plus a whole bunch of compute time to go with it. For so many applications, this means Lambda is pretty much free to get started.
It makes it so easy for developers, for startups, for anyone with an idea to just build without needing a big budget. All right, so you're on board with the idea, but to really become a Lambda pro, you gotta know the little details and tricks. In this last section, we'll get into the power-ups and the best practices for getting the absolute most out of the service.
Okay. It can't all be sunshine and rainbows, right? Every technology has trade-offs, and it's really important to know what they are. For Lambda, the thing people talk about most is a performance quirk called a cold start. So what is a cold start? It's that tiny bit of extra delay you might see the very first time a function runs, or if it hasn't been used in a while. It's the time AWS needs to fire up a new environment, load your code, and get everything ready. For most apps, you'd never even notice it. But for things that need to be lightning fast, it's something you have to plan for.
The good news is there are plenty of ways to beat the cold. You can keep your functions warm by pinging them every few minutes. You can make sure your code is optimized to start up quickly. Choosing fast runtimes like Python or Node.js helps a lot too. But the ultimate solution, the real silver bullet here, is a feature called provisioned concurrency. This is where you just tell AWS, hey, always keep a few copies of my function hot and ready to go. It pretty much eliminates cold starts entirely for a very predictable cost.
Like any service, Lambda has some rules of the road, guardrails you need to work within. As you can see here, a function can't run for more than 15 minutes, so it's not for, super long-running jobs. You also get to pick how much memory it has, from a tiny 128 megs all the way up to 10 gigs. And more memory means more CPU power. And there are limits on how big your code package can be. These aren't really roadblocks, just things to keep in mind when you're designing your application.
Security is always job zero, and Lambda gives you all the tools you need. The number one most important rule is to use what's called least privilege permissions. Only give your function the exact permissions it needs to do its job and nothing more. If it needs to talk to a private database, you can run it inside a secure virtual network, always encrypt your sensitive data, and for things like API keys or passwords, don't put them in your code or in environment variables. Use a dedicated tool like AWS Secrets Manager to keep them safe.
At the end of the day, AWS Lambda and this whole serverless idea, it isn't just another tool in the toolbox. It's a totally new way of thinking about building software. It's a philosophy that puts developer speed, cost savings, and massive scale front and center. By taking the burden of servers off your shoulders, it frees you up to just create, to build cool things. So the only real question left is, what are you going to build? Thanks for joining this explainer.